Correct. So is my screen is visible?
Yes, sir. Visible,
Screen
sir.
visible இருக்கா?
இருக்கு
Yes,
சார்.
sir.
Okay, right, fine. So you can start now, right? So in the IC engine class, in the module 9, we can see the general fuel properties. What are the fuels we are using for the IC engines, and what are the properties, and what is the octane number and cetane numbers ratings, right? So this topic we are going to discuss today, right? Right. So in the IC engines, right? So what is the fuels, right? What is the IC engine fuels? How it can be classified, and how we can manufacture the fuels, and what are the properties or specifications in general, in particularly for the CI engines and the combustion ignition engines, right? So these topics we can see in this class, right? இப்போ எனக்கு இந்த ஆடியபிளா இல்லை ஸ்க்ரீன் விசிபிளா இல்லைன்னா உடனே கொஞ்சம் இன்டிமேஷன் கொடுத்துருங்க, அன்மியூட் பண்ணிட்டு. ஓகேங்களா? any at least yes or no?
Okay, sir.
Okay, right, fine. So the introduction, right? So in the IC engines, the chemical energy contained in a fuel is converted into a mechanical power by burning of the fuels inside the combustion chamber, right? So it is the energy, that is the chemical energy is converted into the heat energy, and then the heat energy is converted into a mechanical output, right? So this is called the heat engine, right? So in the heat engine, so we can convert the chemical energy into a thermal energy, and the thermal energy is utilized for the mechanical output, right? So இதுதான் என்ன சொல்லியிருப்போம், heat engine அப்படின்னு நம்ம சொல்லியிருப்போம், right? So இப்போ நம்மளுக்கு என்ன தேவைன்னா, we have to get a high chemical energy inside the cylinder, right? So how we can obtain the high chemical energy, right? So for the high chemical energy, so what are the composition, uh, or working substance inside the cylinder? That's a very important one, right? Right. So the fuels, right? These fuels which is suitable for the fast chemical reaction, which is used for the fast chemical reactions, then only we can obtain the quick thermal energy, and the thermal energy is converted into mechanical output in faster manner, correct? So அதுதான் என்ன சொல்லியிருப்போம், fuelோட better அப்படின்னு சொல்லியிருப்போம், correct? Correct. So the fuels generally it will be classified into two categories, right? So one is the liquid form of hydrocarbons, and the remaining and all the alternative fuels, correct up by the right? So one is in the form of the hydrocarbons in the liquid form, and some alternative fuels, right? இதெல்லாம் என்ன சொல்லிருப்போம், alternative fuels. And so these are the classifications, right? So these are the classifications for the fuels, which is used for the IC engines, IC engine means either spark ignition or CI engines, right? Compression ignition engines, right? So in this chapter, in this topic, these elements or these contents are a rememberable one, right? So here we can't memorize by the concept wise, right? So we have to remember this term, right? So first, the classification of the fuels, right? So here we can classify the hydrocarbons in the form of the liquid form, that is here it is called as the liquid hydrocarbons, and the alternative fuels. These are the basic classifications, right? In the classification we can see one by one, right? So first we can see the hydrocarbon liquid forms, right? So liquid hydrocarbons, right? So the liquid hydrocarbons is represented by the C and H. That is hydrocarbons, right? So hydrocarbon hydrogen elements as well as the carbon element will be present in the substance, right? So it is represented by C and H, right? That is carbon and the hydrogen. It is carbon and the hydrogen. Then it is represented by some numbers. It is represented by some numbers, right? So here the liquid is general form, that is C some number and H some numbers, right? So depending upon these number, depending upon this content, how much amount of carbon content is there, how much amount of hydrogen content is there, depending upon these content, we can specify a different name. Okay, we can specify in a different manners, right? So the liquid hydrocarbons, it is the fuel. It is the fuel. It is the mixture of hydrogen and the carbon. It is the mixture of the hydrocarbons, right? It is the mixture of hydrocarbons with the bond between the carbon and hydrogen atoms. It is bond between the hydrogen and carbon atoms, right? Then during the combustion, these bonds are broken, and the few new bonds are formed with the oxygen atoms, with some oxygen atoms. So it is accompanied by release the chemical energy, right? So principally the product of the combustion is carbon dioxide and some water vapors. Carbon dioxide and water vapors, and the fuels also contains these contents in a small percentage, right? Oxygen, nitrogen, sulfur, and some water vapors, right? So in this liquid hydrocarbons, we have plenty of subdivisions, right? So in the subdivision, first one is the alkanes or paraffins. Alkanes or paraffins, it is generally represented by, so CN, see here, it is generally represented by CnH2n plus 2. CH, that is the carbon and hydrogen molecules, right? So it is represented by some the numbers, how much amount the quantities, right? How much amount of the carbon are present and how much amount of the hydrogen present, right? So first we can see the alkanes or the paraffins, right? So it is represented by the Cn and H2n plus 2, right? So all the carbon bonds are a single bond. All the carbon bonds are a single bond, and they are saturated, with a high number of the hydrogen, right? High number of the hydrogen atoms, and the heat content is high. And the density will be lower. Its values around 620 to 770 kg per meter cube, right? So these carbon atoms, right, how it is arranged, right? It is arranged by the two manners. One is the straight chain manner, and second one is the branched chain manner, right? So for the straight chain, it is called as the normal paraffins, right? So for the straight, it is called as the normal paraffins, right? So for the first, we can see the what is straight chain group, right? So it is called as normal paraffin, right? It is shorter and stronger bond. It is shorter and the stronger band. It is not suitable for the SI engines, spark ignition engines, right? So why? Because the high tendency for the auto ignition, the value is according to this N value. The value is according to the N value, right? So the N value for the gases is around 1 to 4, and for the liquids it will be 5 to 15. Then we are not using the solid fuel. Fuels in IC engines, right? So for especially for external combustion engine, we can use the solid fuels, but internal combustion engines, we won't use the solid fuels, right? So we can concentrate these two. If it is in the fuel, general form of fuels, we can add the solids also, right? The solid value will be greater than the liquid and the gaseous, right? Liquid and gaseous, the numbers, right? For the gaseous, you can remember it is the range of 1 to 4, and for the liquid, it will be range of 5 to 15, right? So one is the example for the chain is normal paraffin, that is the straight chain, it is hexane, right? So here the value will be, see, it is represented by C6 and H14, right? So here the n value will be 6. Here the n value will be 6. Then generally, which is represented by right. So these are the paraffin which is represented by this form, right? So CnH2n plus 2, right? So for a hexane, the n value will be 6. Then what about the H value? So 2 into n, 12 plus 2, 14, right? So for C6 and H14, right? It is the hexane value, right? So here the carbon will be bond in a straight manner, right? So this is represented by the earlier slides, right? See the carbon atoms arranged how it is in straight chain, right? So it is the symbolic representation of the hexane, right? So here the C will be the 6 terms, 6, and the H will be the 14, right? The H will be 14, right? So all the fuels will be represented by these manners, right? These manner all the fuels are represented, right? Then the second one is how the atoms are arranged. So second one is the branched chain compounds, right? Here it is called as isoparaffins, right? If it is in straight chain compound, it is called normal paraffin. If it is in branched chain compounds, it will be called as a isoparaffin, right? So here, see, when the four or more carbon atoms, in the chain molecule, it is possible to form the isomers. Right? So they have the same chemical formula. It have a same chemical formula for the different structures, right? So for the same chemical formula, and it have some different structures, right? So it is leads to very different chemical properties, right? For the example, isooctane, right? Isooctane. So here also, see, it is represented by C8 and H18, right? So here the n value will be the 8. Here the n value will be 8. So see, so 8 into 2, 16 plus 2, 18, right? So the same, right? So the alkyls or the paraffins will be represented by these hydrocarbon content, or it is represented by some numbers, right? So CnH2n plus 2, which you have to remember this one, right? So for the next one is naphthalene, right? So naphthalene, it is also called as a cycloparaffin. It is also called as a cycloparaffins, right? It is represented by CnH2n, right? So here also it is also a saturated hydrocarbon, right, which is arranged in a circle, and we have, it is a stable structure, and the low tendency to the auto ignition will compare to the alkynes or a normal paraffin, that is the straight chain paraffins, right? So here it can be used for both SI engines as well as the CI engines, and its density is around 740 to 790 kg per meter cube, and it have a low heat content, right? Then olefins, right? So olefins or alkenes, right? So first one is the paraffin or alkanes, right? So first one is the paraffin or alkanes, and second one is the naphthanes, and third one is the olefins or alkenes. Alkanes is different, alkenes is different, right? So here the olefins, it will be subdivide into two, right? So one is the mono and another is a duo, right? Mono and duo, right? So here it is represented by CnH2n and Cn2n minus 2, right? So here the ratio, the carbon and the H ratio is same. It has some carbon and H ratio is same, right? Same general formula for the naphthalene too, right? So why we are using this formula in earlier forms, right? See here, naphthalene, right? So naphthalene also we are using C and H2N. So here also the monofins also using the CnH2n, right? So the general formula will be used for the both naphthalene and the mono olefins, but the behavior is entirely different. But the behavior is the entirely different, right? So depending upon the carbon content, arranged terms, right? So it is also a straight or branched chain compounds with more or one or more double bond. They say it is the this is called the double bond, right? It is called the double bond, right? So the depending upon the position, it will be called as butane and butane. Pentane and butane, right? Then here the density value, right? Here the density value will be around 620 to 820 kg per meter cube, and it have a low heat content, a low heat content, and it can be used for the SI engines, and it can be used for an SI engine, right? So it is obtained by uh, cracking process, right? It is one of the refining process, right? So let me see that what is the refinery process in forthcoming the slides, right? So here is the hexane, right? So hexane, we already gone through what is the hexane. Hexane means we have 6 and H will be 14, right? So we already seen the hexane value where in paraffins, right? So in the paraffins we can see the hexane value, but see, note here, all the bonds are in a single bonds. All bonds are a single bond, but here the bond will be a double bond. But here the bond will be double bond. So the chemical formula will be the same, but its behavior is entirely different. Right? So here the same, the butane. See here it is the chemical formula for the butane, that is duo olefins. Then the fourth one is aromatics, right? So aromatic also a hydrocarbon, liquid hydrocarbon, right? Here it is represented by CnH2n minus 6, right? So here based on the six member, the ring having the 3 conjugated double bonds, right? So we already see these type of reaction in uh, many worlds, right? So why? Because we are using this term. We all we are sorry. We are all know what is the benzene, right? So in school itself, we can study the benzene diagram. What is the benzene diagram, right? So that is the aromatics. Right? Which is used for the SI engines, right? It is to increase the resistance for knocking on CI engines, right? So for the low cetane number, and it is the density is around 800 to 850 kg per meter cube, and it will have a low heat content, right? So these four and the category of the liquid hydrocarbons, right? So what is that? Sorry, what is that? So in the liquid hydrocarbon, we have the four, right? So one is the alkenes and paraffins, and second one is the naphthalene, and third one is the oxyflanes, and fourth one is the aromatics, right? So these four, the category of the liquid hydrocarbons, right? So next we can see what is the alternative fuels, right? So in the alternative fuels, first we can see the alcohols. right? In this alcohol, we can mention here the methanol and the ethanol. Methanol and the ethanol. Right. So alcohol, right? So it will includes the methyl alcohol, that is methanol, and the ethyl alcohol, ethanol, and some propanols and butanols, right? These are the compounds, right? So these compounds are included in the term of the alcohols, right? So here the OH group, right? Here the OH group will be replaces the one of the hydrogen carbons with one of the hydrogen carbons in the form of the alkynes, right? So here its specific heat value is lower. Its specific heat value is lower than the gasoline value. See the value of the gasoline and for the methanol and the ethanol, right? So comparatively these two, while comparing to the gasoline, it will be lower value, right? So the specific heat value will be lower in the alcohols while comparing to the gasolines, right? So for the air fuel mixture, the specific heat value is comparably with the gasoline, it's very low, right? So for the gasoline means we are using the stoichiometric mixture. What is that? It's chemically correct mixture. It's chemically a correct mixture, right? So other the OH groups, other alcohol groups such as dihydralic and trihydralic alcohols are not used in the IC engines. We are not using the IC engine. Only the alcohol group we are using as a fuel in a IC engines, right? So the other alcohol groups, that is the dihydric and the trihydric alcohols, we are not using the fuel. We are not using that as a fuel in the IC engines, right? So in that alcohol, first we can see the methanol. What is the methanol or methyl alcohol, right? So for the methanol, which is represented by CH3 and OH, CH3 and the OH, it is obtained from the natural gas. It is obtained from the natural gas, has near and long-term potential, and the long-term potential has the high octane number. That is a high octane quantity, right? High octane quantity. See, the number will be 130 RON. That is research octane number. Research octane number. Then here the concentration, low concentration, that is 5 to 15% in the gasoline. It is to increase the octane number of the mixture. It is to increase the octane number of the mixture, right? So while using the methanol, we have some problems, right? So what are the problems? So poor soluble in the gasoline and toxicity and the low energy content and high latent heat of vaporization, and the oxygen content contributes the pure divertibility and the incompatible with some metals, right? So these are the problems will be there for the using of the methanol as a working fuel. Then the second one is the ethanol, right? So ethanol is produced from the biomass, and the octane number is here the high value, right? High value of octane number, and it can be used for the low concentration of the gasoline. It's the same content. See here. So the low concentration and the high octane number, right? So the characteristics will be the same for the ethanol and the methanol, but here the difference is it is obtained from the natural gas and it is obtained from the biomass system. Then the second one is the gaseous fuels, right? Gaseous fuels, right? So here in the gaseous fuels, we can for the gaseous fuels, we can obtain from the natural gas. We can get a different type of natural gas, CNG, right? What is CNG? CNG or LPG. So here here we can see only the LPGs, right? So in the CNG we can see in the latter units, right? So what is the LPG? That is liquefied petroleum gas. Then what about the CNG? It is a compressed natural gas, that is called the CNG, right? So due to the storage and the transportation problems, it is not widely used, and it will be reduce the volumetric efficiency and the power output of the engine, and it is for the low tendency to the knock and low emission, right? So these are the characteristics. These are the characteristics. First one is the problem. Why we are not using the gaseous fuel in wide manner, right? So due to the storage and the transportation problem will be there for the using of the gaseous fuel, but it has some characteristics, right? So it will be reduce the volumetric efficiency and the power output of the engine. That, so here we can see only the liquid petroleum gas, right? So the liquid LPG gases, that is liquid petroleum gas, it consists of the propane and the butane. It consists of the propane and butane. It provides a good mixture with air. It provides a big good mixture with air with a cleaner combustion, right? And it has excellent in cold weather performance, right? So for example, if you're going burn with a stove, a LPG cylinder, right? So we can easily burn the contents. We can easily burn that gas, right? So it will have a low sulfur content. It will have low sulfur content, so the emissions will be very low. So the emissions will be very low, and therefore the octane number is high. Octane number is high. For the propane, it will be 111, the research octane number, right? And 100 M1. And here, see the lower density and lower, it will be lower density and low heat content while comparing to the gasoline. While compared to the gasoline, it will be low, right? So due to this low, it will lose the fuel economy. It will lose in the fuel economy. For the better combustion efficiency, it can be reduces its losses, right? So we can see that fuels, right? What are the fuels are there, right? So alternative fuels and hydrocarbon fuels, right? Whatever may be, right? The where we can obtain from these fuels, right? So from the where we can obtain these fuels, right? So all the fuels came from the crude oil, right? So what is that crude oil, right? The crude oil is a liquid part of a naturally occurring the organic material composed widely in most hydrocarbons, right? It composed of mostly the hydrocarbons that is trapped geologically in the underground reservoirs, right from the earth. Right from the earth, you can get a crude oil, right? It is not uniform and it will be varies the density, right? It will be varies the density and the chemical composition and the boiling range, right? In a different fields, right? So these are the refinery process, right? So during this refinery process, we can get the different type of fuels. We can get the different type of products, not only fuels. We can get a different type of products, right? So now we can see the what are the products, right? From the crude oil, we can get depending upon the temperature. See, we can get a different type of product, right? Petroleum gases, gasoline, naphtha, paraffins, diesels, and the fuel oils and the lubricating oils, right? So these are the components. These are the components will be produced from the crude oil by some refinery process. Right? So these are the products. These are the products. See, these are the products. Now we can see what is the refinery process. What is the refinery process? We can see one by one. Sorry. Right. So we have a 5 refinery process. What is that? Distillation process, cracking process, alkylation, polymerization, and isomerization. Right. So these are the refinery process. Right. So by the refinery process, we can get many products from the crude oil, right? So first one is the first process is the distillation process. What is the process? It is the initial process of all the refineries, right? So first one, the first one, the distillation process. It is the initial process which is used for all refineries, right? It is a initial process for all the refineries. It is aimed to separate the crude oil into a different boiling range fractions, right? So different boiling range fractions, we can get a different product, right? So each product uh, in its own weight, in its own right and weight, and a blended component are fed for the further processing, right? So the crude oil contains many thousands of the different hydrocarbons, and uh, each one will have its own boiling point and the lightest or the gases at the ambient temperatures, but it can remain dissolved in heavier liquids of the hydrocarbons, right? So here we can get gasoline distillation temperature is around 35 degree to 200 degrees Celsius. For the jet fuels, it may get 35 to 150 degrees Celsius. For the fuels, that is the diesel fuels, for the diesel fuels, it may get 175 to 370 degrees Celsius. And for the heavy fuels and oils, it may get 370 to 550 degree Celsius, right? So depending upon the temperatures, right? Depending upon the temperatures, we can get a different, see, depending upon the temperature range, see, depending upon the temperature range, we can get a different type of products. Right? Then the second one is the cracking process. Second one is the cracking process, right? So in this cracking process, the cracking process will be in two types. The one is the chemical cracking, and one more is the catalytic cracking, right? So for the chemical cracking, it takes place through the creation of the hydrocarbons freely, radically by the carbon to carbon bonds, right? So the fed is heated around 500 to 600 degrees Celsius at the pressure of 70 to 100 bar, at the pressure of the 70 to 100 bar, and it is passed into the soaking chamber, and it is passed into the soaking chamber. When the cracking taking place, then the cracked products or the fractioned, that is the separated, right? So the product is relatively unstable, and it requires the use of the antioxidants, and it requires some use of the antioxidants and the other treatments to prevent the gum formation, that is the sticky formation, right? It is relatively poor, it is relatively poor in the MON, that is what is the MON? We already see, this time I forgot to tell, right? So the octane number, right? So here we can see what is RON. It is the research octane number, and one more term we are using here, right? That is the motor octane number, right? That is motor octane number, right? So while in the thermal cracking, right? While in the thermal cracking, it's relatively poor in this unit, right? So for the motor cracking, motor octane number, it will be relatively poor in the thermal cracking process, right? Next, the alkynations, right? It is a process for producing the high octane gasoline components by the combining the light oxyflames, right? By combining the light oxyflames with isobutane in the presence of the strongly acidic catalyst, for the strongly acidic catalyst. Then isomerizations, right? So it is a process for converting the light fuels, that is it is the process for converting the straight chain paraffins into the branched chain paraffins used to provide the isobutane for the alkylation process, or it will be converted relatively low octane quality for the high sorry, low octane quality for the straight paraffins, which is most valuable in the branch chain molecules, right? Then the polymerization is a process where the light olefins means the propanes, butanes are reacted together, right? Propanes and butanes are reacted together and give some the heavier content, that is heavier olefins, right? Heavier olefins, which is good in octane quality and low vapor pressure in the gasolines, right? So these are the refinery process, right? Then we can see the next term, fuel specifications or fuel properties, right? So these are the important terms. These are the important terms, right? So what is that? The relative density, fuel composition, specific heat values, flash point, fire point, freezing point, viscosity, surface tension, right? So these are the general fuel properties. These are the general fuel properties. In some specification process also, there some specification specifically for the SI engines and CI engines, right? So we can have different properties, right? Specific properties also there, right? So first we can see the relative density, right? Relative density or a specific gravity, right? So generally the specific gravity is the ratio, right? It's a ratio for the comparison of the standard fluids, right? So the density of the water may be the fluid, and it will be compared with the density of the standard fluid. For the density of standard fluid is water, right? So for the water, the density will be the 1000 kg per meter cube, right? So this term will be studied in fluid mechanics, thermodynamics, in all subjects, right? So what is the specific gravity, which is represented by the S, right? So it is for the density by the density of the standards, density of the standard, right? So for the gasoline, right, the relative density is around 0.72 to 0.78, right, which is equivalent to the AIP index, right? So that is American Petroleum Institute will have a different grading, right? So which is, see here in the density for the relative density for the gasoline is 0.72 to 0.78, which is equivalent to the 65 to 50 API, right? Then the density is around 700 to 800 kg per meter cube for the unleaded gasolines. And for the diesels, the density will be 830 to 950 kg per meter cube, right? So here one more thing we have to remember, right? So when the water's density will be 1000 kg per meter cube, at what temperature? Anyone? At what temperature?
100 degrees Celsius.
Not right. So for the 4 degrees Celsius, the water's density will be 1000, right? So if the temperature increases, what will happen? The density loses, right? இது எப்படி ஞாபகம்? இப்போ தண்ணி சூடு பண்றோம்ல, பாத்திரத்துல தண்ணி சூடு பண்றோம் இல்லையா, ரைட்? எப்படி நம்ம சூடு பண்றோம் சொல்லுங்க? எப்படி அந்த மாலிகூல்ஸ்ல இருந்து ஹீட் டிரான்ஸ்ஃபர் ஆகுது? நம்ம ஹீட் பண்ண நம்மளுக்கு என்ன ஆகும்? டென்சிட்டின்றது லூஸ் ஆகும். டென்சிட்டி லூஸ் ஆச்சு அப்படின்னா அதோட வெயிட்ன்றது கம்மி ஆயிடும். ஸோ வெயிட் வந்து கம்மி ஆயிடுச்சு அப்படின்னா ஆட்டோமேட்டிக்கா லைட் வெயிட் இருக்கக்கூடிய பார்ட்டிகல்ஸ் மேலே போயிடும், ஹெவி வெயிட் இருக்கக்கூடியது கீழே வந்துடும். ஸோ அப்போ செகண்ட் லேயர் ஹீட் ஆகும், ரைட்டா? ஸோ அப்போ டெம்பரேச்சர் இன்க்ரீஸ் ஆக நம்மளுக்கு என்ன ஆகும்? த டென்சிட்டி வில் பி லூசஸ், ரைட்டா? ஸோ இது ஞாபகம் வச்சுக்கோங்க, இது ஒரு கேட் கொஸ்டின், ரைட்டா? ஸோ எந்த டெம்பரேச்சர்ல வாட்டரோட டென்சிட்டி இஸ் 1000 at 4 degrees Celsius, ரைட்டா? ஞாபகம் வச்சுக்கோங்க, 4 degrees Celsiusல வாட்டரோட டென்சிட்டி 1000 kg per meter cube. Okay, right? So we can stop here, right? Next class we can see the other fuel properties and the specific fuel properties, that is the octane number and the cetane number, right? So just we can give some light introduction about octane and cetane number, right? So octane will be used for the SI engines and the cetane number will be used for the CI engines, right? It is for the petrol and it is for the diesel, right? So in our syllabus they are giving octane rating and cetane rating, right? So how it will be differs, right? How it can be specified by uh, uh, the properties, right? So this we can see in the next class. Okay, right? So do you have any doubt in this class?
No, sir.